Okay, so there's been a holdup on the work on our latest build. Something we need to solve soon before the traffic comes in for Minecon.
What's the issue? Is it something with our material shipments?
The workers down on the streets are saying that they're iffy on the tension of our pickup ropes.
Our pickup cables?
I don't know. It's stupid. I was just about to go down and ask about it.
Hey, what seems to be the issue here?
Well, we're ready for your shipment, but I don't know if your cables will be able to hold it up. This amount of TNT blocks can get heavy, you know.
We use top-of-the-line supplies in our work. It'll be fine.
And we take pride in making sure our work is done correctly. We're going to need mathematical proof.
Mathematical proof?
The unpaid freshman engineering interns are coming in from U of H today, aren't they? We'll have them do it.
I didn't expect to get something so heavy on our first day, but they're putting us right to work, huh?
Well, I'm glad to be trusted with the responsibility, I guess.
When did we need this done by again?
By sundown, before the mobs spawn in.
Ah, I see.
We need to find an efficient and quick way to do this.
We can use the 5 steps approach to make this easy.
Sounds good. Oh my god, we have the CEO on Zoom right now.
The CEO? Are you kidding me? It's the first day.
Because this current issue has caused quite the disturbance in our company, and I just so happen to have time in my schedule, I figured I would drop in and gauge the capability of our unpaid UH interns.
Thank you for joining us today, boss.
Interns, if you please.
Hi, we're the unpaid U of H interns working for Imagine Blocks Corp. We've been tasked with solving today's issue with the tension forces.
We needed to find the tension forces that the cables use to pick up a crate of TNT blocks onto a transportation truck.
We can start by identifying the information we know. The crate is 75 kilograms, and the crate is supported by a vertical cable of 2 cables that pass over pulleys attached to 2 buildings.
We've drawn a diagram that we have put on the slide to understand, and we've labeled points of interest as A, B, and C. This cable will be referred to as AB, and this one is AC.
Cable AB is raised 50 degrees from the horizontal, and cable AC is raised 30 degrees. We can assume that the force of gravity has an acceleration of 9.8 meters per second squared.
We were able to calculate the crate has a downward force of 735 newtons. Applying Newton's third law of motion, we can assume the forces of the cable should sum up to equal and opposite forces of the crate, aka an upward force of 735 newtons.
Because we are looking for 2 unknown values of tension forces, we can set up a system of equations to solve for both of them. We know that the tension force of cable AB and the tension force of cable AC should equal 735 newtons.
We can take the tension forces of cable AB and AC and decompose down into their horizontal and vertical components of X and Y. Since the system is not moving in the X direction, we can assume that the X components are equal to 0 and therefore equal to each other.
We multiply the tension force of cable AB by cosine 50 because when the value of the hypotenuse cancels out, we are left with the value of the X component. We set that equal to the tension force of cable AC times cosine 30.
Then, we solve for tension AB in terms of tension AC. Then, we added tension AB times sine of 50, which gives us the y component of AB, and tension AC times sine of 30, which gives us the y component of AC. In total, both y components must equal 735 newtons.
Since we only want to solve for one variable at a time, and we know the value of tension AB in terms of tension AC, we can plug that into our equation and solve for tension AC by factoring out tension AC. Then we can divide both sides of the equation to isolate tension AC and get a numerical value.
Now that it has been established that the tension force of AC is equal to 480 newtons, we can finally go back to our original equation and plug in a value for tension AC and solve for tension AB. After some algebra calculations, we can see that the tension force of AB is 647 newtons. As seen here in our next slide, we can see how in step 4, our summary of the implemented solution strategy we used to do our calculations, where we managed to get the tension of AC is 480 newtons and the tension of AB is 647 newtons.
Thank you for listening to our presentation. Thank you, unpaid UH interns. You've done us a valuable service today.
I think it was pretty impressive, don't you, boss?
Yes, very impressive. But first, I don't trust the hand calculations of a bunch of unpaid engineering interns. Could you present some verification of these results?
Let's bring out the spreadsheet.
Whoa, I can see how well organized and accurate your Excel spreadsheet is. If this were an introduction honors engineering course at UH, I would give you an A+++. I appreciate your account for error, as it displays your understanding of the difference in the rounding of your hand calculations and the Excel's accuracy. It shows you've got what it takes. I think a reward is in order. Unpaid UH interns, if you would so accept it, you may take the positions of these 3 office workers that push their work onto you.
What? We accept.
I guess it probably wasn't the best idea to be putting off such a dangerous task onto our new unpaid UH interns.
The boss was probably more mad at that than us just pushing off our own work, I guess.
I'm glad they seemed to know what they were doing, though. At least the shipment is in good hands now.